For this lesson, we're going to look at writing an equation of a linear function, so writing an equation for a straight line when you don't have any information about the y-intercept. So we know there's this form of an equation, y equals mx plus b, where b is your y-intercept. If you were just given this diagram or this graph shown, you don't see a y-intercept, so you wouldn't be able to use this equation. What can we do? Well, we know we can calculate the slope using 2 points, so let's start with that. Let's choose this point as point number 1 and this point as point number 2. And I'm going to say that in general, so I'm not talking about this specific line, but just in general, we'll say point number 1 is going to have an x value of x1 and a y value of y1. And point number 2, instead of saying point number 2 has an ordered pair of x2, y2, I'm just going to call this x and y. That's the name I'm going to give it. So the first thing we're going to do here is we're going to calculate the slope. So m equals the rise, which would be y minus y1, divided by the run, which would be x minus x1. And for step 2, what we're going to do, so step 2, we are going to multiply both sides by x minus x1. So we're going to multiply this by x minus x1. Okay, so what's the result? On the left side of the equation, you have m times x minus x1. That is just m times x minus x1. On the right side, the x minus x1 on the top divides by x minus x1 on the bottom. Any number divided by itself is 1, so that just goes away. So on the right side, you're left with y minus y1. And I'm just going to flip the equation so that I'll have the y's on the left side. So we have y minus y1 equals m times x minus x1. And this is an equation, right? It has an equal sign to it. And this is an equation of a line. It shows the relationship between an output value of y when you have given it an input value of x. And this form of equation is called the point slope equation. So I just rewrote it to be bigger for more emphasis. This is the point slope equation of a line. You have your output variable and your input variable in the y's and the x's. You have your slope, which is m. And then you have these variables x1 and y1. And what x1 and y1 are an ordered pair along the line. So just a point along the line, any point at all. So if you know any point along the line and you know the slope, you can write an equation of that line in this format. You don't need that y-intercept. Let's look at an example. In the box is the point slope form of the equation of a line, and we want to determine the slope and a point using of A and B, of the equations A and B, and then graph those equations. So let's start with slope. So for equation A, you can see that your slope is the number that is next to the x minus x1 in brackets. So your slope in this case is 2 over 3. Slope has a rise of 2 versus a run of 3. And your x1, right, it's x minus x1. And in the brackets for equation A, you have x minus 1. So 1 is your x1. x1 is 1. And now look at y1. If a minus y1 equals 3, then y1 must be negative 3. So I'll write this explicitly for now, but we'll do it faster later. But if negative y1 equals 3, multiply both sides by negative 1, and you'll have y1 equals negative 3. Therefore, your point, so the point that we have listed in that equation is a point with an x value of 1 and a y value of -3. So let's graph that. We'll start by graphing our point. 1, -3. Here's 1. Here's -3. And then we can graph our next point with the slope. The slope has a rise of 2, 1, 2, a run of 3, 1, 2, 3. That's the next point. We can even do another point to make sure our line's nice and straight. 1, 2, up, 1, 2, 3 across. And we can draw a line like so. Okay, let's look at example B. So for example B, your slope equals -3. Now, your x1 value must be -2, where your y1 value is just 2. So your point is -2, 2. So to graph this, let's start with finding the point on the graph. -2, 2. So -2 for x, +2 for y. That's your point right there. Our slope is -3. So that's a rise of -3, or we're falling 3 for every 1 across. So down 3, 1, 2, 3, 1 across. And we can do that again. 1, 2, 3, 1 across. And we can draw a straight line through those points. So that is line B, and red is line A. Now let's say we were just given a graph and we want to determine the equation of that line. Now, I could decide to use the slope-intercept form of this line because I have the y-intercept here, but look, this is an inexact value, right? It's not on a crosshair. So I don't know for sure, like this is likely, -3.5, but I'm not certain. So I don't want to use that point. I can instead use points that I know, right here and right here, calculate the slope, and then use one of those points to write the equation in this point slope form. So let's do that. Let's say this is our point number 1, and this is our point number 2. Point number 1 then would have an x value of -1, 2, 3, and a y value of 4. Whereas point number 2 would have an x value of -1 and a y value of -1 as well. Okay, so the slope would equal your y2 minus y1 divided by x2 minus x1. So that's a -5 over 2. And just recall the form of this new equation we're dealing with. Y minus y1 equals m times x minus x1. We know we can fill in the information of the slope, that's just -5 over 2, but remember x1 and y1 are any point on the graph. You know 2 points already, point number 1 and point number 2, so which one do you use? Whichever one you want. So I could use point number 1, which in that case, my equation would be y minus 4, because that's the value of y1, equals the slope of -5 over 2 times x minus x1. x1 is a -3, so that's like a minus -3, which is a positive 3. If I decided to use point number 2, I can do that. Then my equation becomes y minus -1, so that's a y plus 1, equals the slope of -5 over 2 times x plus 1. Basically, if your point is negative, in the brackets you write a positive. But even though these two equations don't look exactly the same, they are. They describe the same line. You just have 2 different points listed on your equations. But those equations are equivalent. Now let's try to go back and forth between our different forms of equations for a line. Here we have a line that passes through point A and B, and we're going to first write the equation of that line in point-slope form. Then we're going to take that and write it in slope-intercept form. So first step would be to determine the slope. Slope, which is y2 minus y1 over x2 minus x1. In this case, we can say yb minus ya divided by xb minus xa. We'll have 2 minus 5 divided by negative 1 minus 3, which would give us negative 3 over negative 4. Negatives cancel each other out, so your slope is 3 over 4. Okay, now we can take any of those points. Let's just take point A and write this in point-slope form. Y minus y1, which would be 5. This would be y1, this would be x1. So y minus 5 equals the slope of 3 over 4 times x minus the x1, which is 3. Well, so x minus 3. And that is the equation of that line. We can take that form of equation and convert it into slope-intercept form. So let's remind ourselves what slope-intercept form looks like. Slope-intercept form is y equals mx plus b, where b is the y-intercept, m is the slope. Now, a couple of things stand out to me about this form. One is, well, you have y by itself on one side of the equation, and on the other side of the equation, you have everything else. So on the other side, you have everything else, plus there are no brackets. So essentially what we're going to want to do is take our point-slope form and rearrange it so it looks like slope-intercept form, where you have y on one side, everything else on the other side, with no brackets. Okay, so let's take our point-slope form. So we're starting here with y minus 5 equals 3 over 4 x minus 3. And we want to get rid of the brackets, right? No brackets in y-intercept form. So how do we deal with no brackets, or how can we get no brackets? We can distribute through them. So we can say that we have 3 over 4 times x is just 3 over 4x. And 3 over 4 times negative 3 is negative 9 over 4. The left side remained the same, that's just y minus 5. Okay, next step, get y by itself. So what can we do for that? We can add 5 to both sides. Where we'll end up is y by itself equals 3 over 4x minus 9 over 4 plus 5. Now we need to add like terms. So we're going to need to add these two numbers here together. How can we add that? We have to add fractions. So y equals 3 over 4x. Negative 9 over 4 and 5 need to have the same denominator. So we can say this is negative 9 over 4. The 5 becomes 20 over 4. And then finally, you'll have y equals 3 over 4x plus 11 over 4. And that would be slope-intercept form. You have the slope times x plus the y-intercept. Y on one side, everything else on the other side, no brackets. Okay, what if you don't like playing around with fractions? You can get rid of the fractions first by multiplying by the denominator. What do I mean? Let's do this again. This time we're going to eliminate the fractions as our first step. So we have y minus 5 equals 3 over 4 x minus 3. So that's our starting point, the point slope form. Now, what we're going to do is we're going to get rid of this fraction first, and we'll do it by multiplying by the denominator 4. So we're going to multiply the whole right side of the equation by 4, and we're going to multiply the whole left side of the equation by 4 as well. So let's look at our result. On the left side, we'll have 4 times y minus 5. So 4 times y is 4y. 4 times negative 5 is negative 20. On the right side of the equation, we have 3 numbers multiplied by each other. 4 times negative 3 over, times 3 over 4 times x minus 3. So you basically just multiply the 4 by the 3 over 4. And then that gets multiplied by x minus 3. 4 times 3 over 4 is just 3. So really, the right side of the equation becomes 3 times x minus 3. Okay, and then in the next step, you want to get rid of those brackets. So distribute that 3 across the brackets, and you'll have 4y minus 20 equals 3x minus 9. Now we just want to isolate for y, so we're going to take that 20. We want to add 20 to both sides so we can get rid of it. So you'll have 4y equals 3x minus 9 plus 20. And let us combine like terms. That's 3x plus 11. And finally, for the last step to isolate y, you're going to want to divide both sides by 4 to get y by itself. As a final result, you have y equals 3 over 4x plus 11 over 4. So I did this in detail, but you could probably do it in less steps, but I just wanted to show you the detail of rearranging equations. There's 2 ways, right? You can either live with a fraction and add and subtract using fractions, or if you don't like fractions, in your first step, you can get rid of the fraction by multiplying both sides of the equation by the denominator of your fraction. Okay, let's look at the last couple of examples. For number 5, we're asked to write the equation of a line that is perpendicular to the line of y equals negative 3 over 5x minus 4, and it passes through the point r is 6 and 1. So for here, let's look at the slope. The slope of the line that's given to us is negative 3 over 5. Our line is going to be perpendicular to that. So the perpendicular slope we know is the negative reciprocal. Negative meaning if we had a negative, now our perpendicular line is going to be positive. And then the reciprocal of 3 over 5 is 5 over 3. So that's our slope. And then it says that our line passes through the point 6, 1. So we have a slope and we have a point given to us, 6, 1. So we can plug that into point slope form. Y minus y1, which is 1, equals the slope of 5 over 3 times x minus x1, which is 6. So to be clear, we're given a point, that is x1, that is y1, and you just plug it into the point slope form, and that's your equation of the line. Next example, we have a line, or we want to write the equation of a line that's parallel to this line that's given and has the same horizontal intercept as this second line that's given. Okay, so what information do we want? We want the slope first of all. So the slope of the first line that's given is 4 over 3. Our line is going to be parallel to that. So the slope of the parallel line is the same, 4 over 3. Now, it gives us the point of a line. It says we have the same horizontal intercept as this. Horizontal intercept, that's the x-intercept. Well, the x-intercept, we know that happens when the y value is 0, right? That's when you get x-intercept. So what we'll do is we'll take that line, y equals 4x minus 8, but we'll set the y value to 0. So 0 equals 4x minus 8, and then we solve for x. Right? So what can we do to solve for x? We'll add 8 to both sides. I'll just say here we're adding 8, and that's for both sides. So you'll have 8 equals 4x. And then you still want to isolate for x, so you'd want to divide both sides by 4. So 8 divided by 4 is 2. 4x divided by 4 is x. Okay, so your x-intercept is 2. So if your x-intercept is 2, you can use that as a point on the graph for point-slope form. Your point on the graph would be x value of 2, y value of 0. So when writing point-slope form, this is your x1 value, this is your y1 value. So what's point-slope form? Y minus y1, in this case 0, equals the slope, 4/3, times x minus x1, in this case 2, and that is your equation in point-slope form. And that's the lesson. Hope you found that useful. Thanks.